In the last lesson, we were numerically trying to figure out the optimum volume of a three-dimensional shape. So the shape had to have a surface area of 1,000 meters squared, and we were trying to figure out the best shape and the best dimensions, the best, in this case, radius and height of a cylinder, to get the biggest volume. And we figured out that about a radius of 7 and a height of almost 16 gave us the best volume. So it's a little bit tricky if we wanted to get it to 2 decimal places or 3 decimal places for the radius or height, because we would really have to play with these numbers for quite a long time, get a lot of guess and check. It would take some time. It would help us if we could come up with an equation and do some graphing. So notice that we were picking the radius and then figuring out the height. And every time we did this, we would have 1,000 equals 2 pi r squared plus 2 pi r h. We would know what r was, and we would bring it over to the side with the 1,000 and solve for h. So in general, we are subtracting this term from both sides to move it over. Minus 2 pi r squared equals 2 pi r h. We're trying to get h by itself. The 2 pi r is multiplying the h. To get rid of it, we divide. Okay, let's simplify this a little bit. H is equal to 1,000. If we wanted to, there's a common factor of 2, we could divide things out. That might be a good idea. 2 goes into 1,000 twice, leaving 500. 2 goes into 2. Notice I divide the 2 into every term, so it's dividing everything. 2 goes into 2 evenly, it'll be canceled out. So this gets canceled, and this becomes 500. Pi r squared over pi r. We can't simplify this any further. If you left it as 1,000, if you left it exactly as it is up here, that's fine. This just means a little bit less to type. Okay, so, and then we took our h and we took our r and we figured out the volume. So the volume is equal to pi r squared times h. Now we have a term for h. Once we've picked an r value, we can find the h by doing 500 minus pi r squared all over pi r. So we could actually take this and graph it. You haven't done a lot of graphing like this before. We could just take the points and graph them, but today I'm going to show you how to use GeoGebra, and we're going to graph this. Hopefully it's not so out there, it doesn't, that it doesn't work. Hopefully it'll work nicely, so let's give this a try. So it's not going to let me use r, I'm going to have to use x. So I'm going to do pi. I hope it figures out what pi is, I think so. R, power of 2. There we go. My keyboard was in French. It did not like it. Pi times r squared. Oh wait, I said we're not using r, we're using x. Pi r squared times 500 minus pi times r, we're not using r, we're using x to the power of 2, divided by, now notice if I do the divided by like this, I'm dividing only this last term. I want to divide everything. So by order of operation, I need to put this in brackets. So it'll all be divided by pi x. Now I'm not sure if I did the pi correctly here. And you know what? I see I have a symbol button. I bet it wants me to use this symbol button for pi instead. Let's try that. I'll just try graphing it, see if it lets me. Create a slider for pi. No, I don't want to create a slider for pi. I know what pi is. So we could either put 3.14 here, or we could use the symbol. I think I'll do 3.14. All right, let's see if it'll graph it. It graphed it. Excellent. The only problem is we can't see all of it, so we need to adjust the axes here. We're trying to see the shape of this graph. We're trying to figure out what the maximum volume is. And we knew from what we did over here, we know the maximum volume is about 2,400, about 2,400. And I'm at about 1,200, so I have quite a bit more to go. There we go. There it is. There's the maximum value. It's right around here. If I can place a point on it, I could drag this point around till I see the highest number, 24.28. No, I want to see a little bit more here. Okay, 28.49. Now it's going down. 28. Okay, I think that's the best I can do. So with a radius of 7.28, our maximum volume would be 2,400. For a cylinder, is the cylinder the best shape? Let's figure out what it would be for a square-based rectangular prism. So for a square-based rectangular prism, it would look something like oh, that is not a very nice square. Let me try one more time. Okay, not too bad. So the bottom here is the base B, and up here is the height H. So we have surface area is equal to the bottom part and the top part are base squared, and all the sides, there's 4 sides, that would be H times B, or B times H. Okay, so this is what our surface area is. In the last question, we would pick one thing and find the other. So maybe we pick the base and then guess the height. Pick the base, guess the height. We have 1,000 is equal to b squared plus 4bh. So similar to the cylinder, we can isolate the h. So 1,000. First we try to get this term away from the h. Minus b squared is equal to 4bh. Get rid of the 4b to get h by itself. H is equal to 1,000 minus b squared over 4b. Okay, so we have an expression for h. Just like with the cylinder, we did some work we would guess the r and find the h. The h value, we based it on the radius. Now we're basing it on the base. And the volume is usually length times width times height. Length and width are both b, so bh times height. So we have an expression for the height. We can put that in for the height. 1,000 times b squared all over 4b. Okay, we can put this over here. We're going to have to use x's, and we're going to have to be careful with the division. When we put it over here, we're going to put the whole numerator here divided by the whole denominator. Those extra brackets, make sure that we have the whole numerator together and the whole denominator. So over here, b squared, so we need x squared times bracket, 1,000 minus x squared, all divided by bracket 4x. And I didn't even type b, I really thought I would. I have all the brackets I need. I was really expecting it to look different. I thought it would be similar, but it's much, much lower. So let's look at this equation and see what's going on. It was supposed to be 1,000, and I made a mistake and I wrote 100. Now let's see. Okay. This looks more like the cylinder. That makes more sense. So the maximum height, we're doing, the volume is over here on the vertical axis, and the bottom is the x value. So the x value for the rectangular prism, the x value represents that base length, okay? And for the cylinder, it represents the radius. Okay, so for here, let's try to find a point that looks like it's the maximum volume, the optimal volume. So we have 24, 3,042, 3,042.9. Oh, now it's going down. Okay, that's probably pretty close to the maximum. So we have an x value of 18.4 and a maximum volume of 3,000. Why these numbers? Why are these numbers important? Well, if the base is 18 by 18 for this rectangular prism, let's figure out what the height would be. So if the base is 18.24, the height is 1,000 minus 18.24 over 4 times 18.24. I'm going to put this in my calculator and figure out what the height would be, and we'll see what kind of a rectangular prism is this. What are the dimensions like? So for the height, I got 13.456. Okay, so they're pretty close. The base values and the height are pretty close. Okay, for the, I was expecting a cube. I'm not sure why it didn't work out to be a cube. It's usually a cube. I'll have to come back to this. Maybe I made a little typo. For the cylinder, notice that 7.2, well, when we had up here, 7 and the 15, were, it was pretty much half of the height. When the radius was half of the height, then it worked out to be the maximum volume. So in this case, the radius is half of the height, and the diameter is equal to the height. So you get a maximum cylinder, maximum volume cylinder, when the diameter equals the height, or 2 times the radius equals the height. For the cube, it should be, for the rectangular prism, it should be a maximum when the height is equal to the base. It should be a maximum when it's a cube. So there's a mistake in here somewhere.